right, margin of error. Okay, I just have a few notes that I want us to take with this. Margin of error is all about confidence. Okay, it's a confidence interval. So this is actually very helpful when you are looking at any kind of statistic that they give you in the news. The most applicable time that margin of error comes into play is when we're looking at a presidential election or something like that. So if you ever pay attention, when the news reports that based on a survey done by Quinnipiac, candidate X is predicted to receive 53% of the vote, and then it always has that plus or minus 4%, or plus or minus 7%, or plus or minus 2%. You ever wondered what that plus or minus is supposed to mean? Well, that plus or minus whatever percent is something that we call the margin of error, and it means that they are 95% confident that that candidate will receive between, you got to subtract it from the percentage that they report, so 53 minus 4% gives us 49%, and then you add it to the percent that they report, so 53 plus 4 is 57% of the vote. So the bigger your margin of error, the wider your possibility is. So you really want the smallest possible margin of error when you are trying to report these things, because it means you have a higher confidence in what you're talking about. Okay, so the standard is a 95% confidence. We can never say that we're 100% confident unless you say that it's between 0% and 100%. Okay, it's the only time that you can have 100% confidence in your result. Otherwise, you're always going to have there's always going to be the possibility that it's outside of the predicted range. Okay, so we're always 95% confident that if we take our percent and subtract the margin of error, and then take our percent and add the margin of error, the actual percentage is somewhere in between those two values. Okay? So let's look at example 1 right here. It says Senator Smith and Miller are in a close election. Senator Smith is projected to get 52% of the vote, so he's projected to win, but there's a 5% margin of error. So he's projected to win, but there's still a possibility that he may not get that percentage of the vote. So the highest amount of the vote that Smith is projected to get, we take the percent and we add the margin of error. So in this 95% confidence interval, the highest percent of the vote that he's projected to get is 57%. Now, that is not to say that in the actual election, he wouldn't get 60% of the vote. Okay, this is just based on a survey of a certain number of people. That's why there's only a 95% confidence. He could get more than 57% in actuality, but this is just what the statistics are saying. The smallest amount of vote would, you take your percent and you subtract the margin of error. So the smallest percent would be 47%. So there's a 10 percentage point range here because we have a 5% margin of error. Let's look at part C. What's the highest amount of the vote that Miller is projected to get? Well, Miller would get the highest percentage of the vote when Smith gets his smallest percentage, right? The other candidate would get the highest percentage when the candidate that we're talking about gets the smallest percentage. So if we take 100% minus the smallest percent that Smith is projected to get, then Miller could win this election. If Smith gets the smallest percentage, Miller could win with 53%. Even if he didn't get his smallest, if he got 48, 49, 50, that would be a tie. But that's the highest amount that he's projected to get. Any questions about that right there? Okay. Let's look at this right here. The percentage of people that speed through a town is between 35 and 43%. It's between 35 and 43%. What is the mean percentage of people who speed and the margin of error? What is the mean percentage of people who speed and the margin of error? So if this is our range, okay, what number would be right in the middle? Just like we did with that question, let's add them together and divide by 2. So that's going to give us, what, 78 divided by 2. So right in the middle is 39%. Okay, so 39% is the mean percentage. The margin of error, we have a range of 8. So if we divide that by 2, we have a 4% margin of error. I'm going to abbreviate that MOE. Okay, so if they give you the low percent and the high percent, then you find the percent right in the middle. That's the actual percentage. And then the margin of error, take your range divided by 2. Yes. The 8, it was a range, 43 minus the 35. Good question. I should have written it down. Any other questions? All right. Let's look. Sorry, I'm trying to figure out these tools here. On the next slide. Nope, that's not working. Just restart here. I'm stuck on a pin. I can't get off of it. There we go. Let me try that again. Calculating the margin of error. Okay, what if we have to calculate the margin of error? The margin of error is 1 over the square root of n. The margin of error is 1 over the square root of n. N is the number of people in the sample. So if you do a survey, if you do a poll, if you do an experiment, whatever you're doing, the margin of error is 1 over the square root of n. Now, this is not the only formula for margin of error. Okay, it's not the only formula for margin of error, but it's the one that we use in this context. Okay, there are other ways of calculating it in other situations, but we're going to use 1 over the square root of n. All right, so in a poll of 150 students, 78% said that they liked their teachers this year. So let's find the margin of error. If we have 150 students and we want to find the margin of error, it's 1 over the square root of the number in our sample. So we have 150 students in our sample, so it's 1 over the square root of 150. You're going to have to convert that to a decimal value. Or, well, it is a decimal, excuse me. You're going to have to convert that to a percent. So as a percent, move your decimal 2 places. 8.165% is our margin of error for this sample. So our certainty statement, we can say we are 95% certain that the percent of students we are 95% certain that the percent of students like their teachers is between, we got to take that 78% and subtract the margin of error, 8.165. So the low end is 69.835%. And take the 78 and add the 8.165%. So the high end is 86.165%. In this application, yes. Yes. There are other ways to have other ranges of certainty, but we're just going to go with 95% certainty with this. If you take another statistics class, you'll look at computing if you want 98% certainty or 99% certainty. There are other ways to compute that. All right. So I've got some practice problems.